Yeah, good. Okay. It, it looks like that some of you has left. So the reason for having the policy of 40 minutes, because we believe that some of the students could leave at the beginning and they okay say we do have the record, so let us leave, and then we're going to listen to the record. This is not good idea. This is not good idea. So this is why I prefer to use Zoom, because it could give me the 40 minutes policy, so I could know who has left and who has stayed with me. Right now I have only 4 names. I hope the others will be able to join me later. Okay. Oh, let me.
Um,
Yes.
sorry, sir.
Yes.
Sir, just sorry for interruption, but like, uh, like if we don't solve us examples, we cannot understand the material very good.
You do not understand the material.
Like we don't get it like 100% if we don't like see like
O-
example.
okay. Okay. Let me see. Let me explain something to you. Whenever that you think you are lost, whenever you think that you couldn't understand me, whenever you couldn't catch me, say, sir, please repeat yourself. Now tell me where you could not understand me, so I could explain it more and more. It's not about how much I could cover. I mean the materials, the topics that I could cover. It is more important that you could understand me. So please let me know which things that you need me to explain them more. Are you talking about examples? Yes, of course, we will have a lot of examples, but not now. Let me finish these topics. I mean the natural gas properties. Then we will have a lot of examples, solved examples.
Sir, if you repeat just the part of how to find y, just like very quickly, if you repeat it,
Yes,
that
yes,
really
of course, yes, of course. Please,
thank you.
now and later, whenever you think that you are lost, stop me. See what I'm saying? Whenever you think you are lost, stop me. Say, sir, I do not understand this point. Please explain it more. It will be my pleasure to do that. Is it clear?
That's great, sir. Yes, sir, that's great.
Oh,
Thank you very much.
okay. I'm gonna get back to y. How to calculate y? Is it this point? Y?
Yes, sir. Yes.
Okay. Now, as I said, we have two options. We have two options to calculate z factor. One of them, the graphical solution. I'm not going to go with this one. I guess that you have understood how to calculate z by the graphical solution using z chart. Now, the second option to calculate z is the analytical solutions. Now, for the analytical solutions, we have three techniques or three methods. Hall-Yarproof method, Drunchuka Abu Qasim method, Drunchuka Parviz Robinson method. We will not consider Drunchuka Parviz Robinson. It is written in the textbook, so you can go to the textbook and get the details of Drunchuka Parviz Robinson. It is similar to Drunchuka Abu Qasim. Okay, oh good. So let us start with the first one. The first one is Hall-Yarproof. Hall-Yarproof method say that z can be calculated by what? Z can be calculated by this model. See, here is the model to calculate z. This is the model. So z can be calculated using this model. 0.06125 ppr. What is ppr? Pressure, reservoir pressure, divided by ppc. And we know how to calculate ppc. T, what is T? Reciprocal of what? Reciprocal of TPR. What is TPR? Reservoir temperature divided by what? Divided by TPC. And reciprocal, it means that TPC divided by T. So we know how to do that. So we know how to get T. Now we know how to calculate PPR. We know how to calculate T. This is T. The only missing part is here is Y. So we need to know how much Y. To calculate Y, we're going to go with what is called the trial and error. Have you heard about trial and error? Iteration method, iteration calculation. Have you used this one before?
Not really, sir, no.
Okay, good. Now,
No, sir.
yes, so we need to know how much Y. Y is calculated by the iteration method or by trial and error method. Now, what is the condition for Y? Because for the iteration method, there should be a condition that you have to stop with it. Now, the condition for this case is this. This is your condition. See, we have a function called fy. We have a function called fy. Fy is what? X1 plus y squared plus y cubed plus y4, 1 minus y all cubed minus x2 y squared plus x3 y to x4. This function fy should be equal to 0, must be equal to 0. Okay. Now x1 is calculated. We know how to calculate x1. There will be no problem with x1 because x1 is a function of PPR and T, and we do have both of them. X2 also function of T, X3 function of T, X4 function of T. So we do not have a problem with X1, X2, X3, X4. Now the problem with Y, how much Y we don't know. How much Y we don't know. But there is a value for Y that could give you Fy equal to 0. There is a unique value. There is a single value for Y that could validate the function Y that is equal to 0. Is that clear? Is that clear so
Yes,
far?
sir.
Now,
Yes.
we need to know how much Y that could give you Fy equal to 0. Okay, now we are going to start our trial and error. We will try and see. We will try and see. We will try and see until we will reach the value of Y. See what I'm saying? Until we will reach the value of Y. Now, how can we start? Here is the point. Which value we should start for Y? The first value of Y is determined by this model. The first value of Y is determined by this model. Do we know PPR? Yes, we know PPR. Do we know T? Yes, we know T. So we're going to put them, so what we will have Y1, because this is the first trial, the first attempt. So this is Y1. Now, Y1, we're going to put it where? Where we will put Y1? In the main model of Fy. See? In the main model of Fy. So Y1, the one calculated from this one, we're going to put it where? We're going to put it in the main model of Fy. We're going to put it where? We're going to put it here. See, guys? Here. And we will solve this one. Is it 0 or less than 10 to the power minus 2? That's 0.0000001. If it is 0, then this is our Y. If it is Y, then you can get back here and put it here and calculate Z. And this is your Z factor. But if it is not equal to 0, it is greater than 10 to the power minus 12, then what you have to do, you have to look for another Y. Okay, how can we calculate the second Y? The second Y is calculated by what? The second Y is calculated by this model. See, this is the model for the second Y. Here is the model for the second Y. See, the second Y, the first Y minus the value of the function of Y, using y1 divided by the value of f dash y1, f dash y1, the first value of y. How can we calculate f dash y1? Here is f dash y1. So we know y, y1, 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 x2 already calculated, y1, x3 already calculated, x4 already calculated, y1, x4. So this is f dash. You're going to put it here. You have this one already calculated from y1, and this is y1. This is this is your y2. Now, when you got y2, you are going to go where? Go back to what? Go back to fy here. You are going to go back to what? Fy here. See? You're going to put y1. So this time going to be y2. y2, 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 y2. Of course, you know x1, it's not going to change. You know x2, it's not going to change. x3, it's not going to change. x4, it's not going to change. You're going to calculate them once. And from y2, when you're going to put y2, you're going to solve this model. Is it 0? If it is 0, then y2 is your y. Then you're going to calculate z. But if it is greater than 10 to minus 12, then you have to look for another y. That is y3. What is y3, guys, in this case? y3 in this case, what it will be? y3 will be y2. See? y3 in this case. y3, this is y3. You're going to say y3. y2 minus fy2 divided by f dash y2. So you will have a new value for y3. Again, you're going to go to the main model for y, put y there, and get fy. See if it is 0. Good. This is your y. Not repeat everything. Is that clear?
Okay, sir. But what do you mean by fy2? Like what this is fy2? What's fy2?
Okay.
Like, yeah.
Okay. Okay. Do you know if we solve an example, it will be very clear to you. Okay. let me get back.
Yeah. Okay, that's why last year I want like example, just like to make things.
Yes, I know, but listen.
No problem, sir. Yeah.
No. Listen. I do not blame you. I do not blame you. From my teaching experiences, that is more than 30 years. We're going to lose our time when I put the examples while I am lecturing. So I prefer to finish everything. Then we will have the application. We're going to solve a lot of problems from chapter 2, Tariq Ahmed. But if there is something wrong, okay, good. Never mind. I can re-explain everything. When I said, listen, this is your condition again. What's your name, sir? What's your name? Just let me know. So what's your name? Ahmed?
I'm Francis.
What?
Furat.
Huh?
Furat, sir.
Furat.
Furat.
Yeah, Furat. Listen to me. Furat. This is our condition. This is our condition. See, this is our condition. We're gonna have this model. This is our condition. This model can tell you which y is this. We need to get a value for y that could validate this model. Fy should be equal to 0 or must be equal to 0. Now, x1, x2, x3, x4, all of them known. The missing part is y, and we do not know how much y. This is why I said what you need to go with the iteration method. Now, how can we start with y? How can we start with y? We don't know how much y is. But Al-Rbeawi said you can have the first estimation for y. This is y1, see? Yk. K is counter, yk. This is, see, yk. So k is counter. So we're going to, with k1, we're going to assume that k1. So this is y1. It means the first value of y that you're going to put into the model. And y1 is calculated by this model. And we know this one, we know this one, we know this one. So it will be very easy. Now y1, we will put it where? y1. So is it clear how we get y1?
Yeah, sir. Yeah.
Oh.
Yeah.
So now y1 in your hand. y1 in your hand. Now you will get back to where? You will get back Farad, you will get back to the condition. This is the
The
condition.
main equation. Yeah.
Yes. You know x1, you know x2, you know x3, x.
Yeah. If it's not equal to 0, you will find y2.
Exactly. You're gonna put y1 here, and you will check this model. Is it 0?
Okay.
If it is 0, this is your y.
Yeah.
Then you can get back to the model for z here and put y here. See? Put
Yeah.
y
Yeah.
here.
Yeah.
Now,
Yes, sir.
if it is not 0, if it is not 0, or let
We
me
need to
say,
find y2.
if it is greater than 10 to the power minus 12, then you need another y. See? Then you need a new y. The new y is called y2 because you have used y1. See what I'm saying? Now you need y2. How can you calculate y2? Y2 is calculated from what? Y2 is calculated where? By this model. This is y2. See? Is that clear so far?
Yes. Yes.
So this is y2. Y2 is calculated from y1, the y1 that you have,
Yeah.
and
Yeah.
that y1 does not validate your model, but you
Yeah.
have
Yeah.
y1 in your hand.
Okay.
The function of y when y1, the function of y when y is equal to 1, you know how much?
Oh, you mean like this value is from the main one, right?
No, y1, you still have y1 in your hand. You still
Yeah.
have
Yeah. Yeah.
y1.
Fy1 is the value from the main equation. That's
Yes, yes,
that equal
yes,
to
yes,
0. Oh, okay.
yes,
Okay,
yes,
sir.
yes,
That's
yes,
why my
yes,
question.
yes. The value here, the value of y here, the value of y here. It is not gonna be 0. How much?
Yeah. 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 Okay. Okay.
You are
Okay.
gonna put it here. You are gonna put it here. See, you are gonna put it here, and f dash y1, f dash y. Here is f dash y1. This one, but instead of y, you're gonna put y1, 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 y1.
Okay,
See,
sir.
and you're gonna put it. So now you will have what? You will have y2 in your hand. Is that clear, Farad?
Yes, sir. Now everything is clear. Okay.
Now you're gonna repeat yourself. If y2 is good, okay, good. You're gonna calculate z. If it is not good, what you need? You need y3.
We go back to this equation, but
Yes.
instead of okay.
Exactly. See what I'm
Okay.
saying?
Yeah. 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 Okay.
Great, great. Okay. So now for Dranchuka Abu Qasim, same protocol, but instead of fy, we're gonna work with what? F rho r. F rho r. This is the condition. See, this is the condition. So what we have R1, R2, R3, R4, R5, A11, A11 actually, A11 here, and R1 as you can see defined here, and we have A1, A2, A3 until A11, and all of them are explained here. One thing I need you to consider, see guys here, AR, see guys here, A sub T. This is actually A4. This is actually A5. They are written in the textbook mistakenly. They are written in the textbook mistakenly. They should be A4, A5. So next week I'm going to change them to A4, A5. But when you go to the textbook, Tariq Ahmed chapter 2, you're going to find AR, AT. They are not AR, AT, they are A4, A5. Is that clear? Is that clear?
Yes, sir.
Okay. Now, the protocol for this case, what you are going to do, you're going to start with the condition, but this time you're going to what? You're going to calculate rho R1. This is rho R1, see? Rho R1. Rho R1 what? 0.27 PPR given, TPR all known. Both of them known. So this is rho R1. Rho R1. And rho R1 will be used where? The main model. What is the main model? This is the main model. The condition, see, this is rho R. You have R1, you have R2, R3, R4, R5, A11, A11, you have all of them. So you're going to put rho R1 square, rho R5, rho R square, rho R square. You are going to put the rho R1 here. If the function of R rho equal to 0, then your rho R will be used here, and then you are going to calculate Z. from this model. If it is not, you're going to look for a new rho r. Now, the new rho r is calculated by this model. The new, see, this is rho r2. Rho r1, the one in your hand, the function of rho r already from the model, the main model, and f dash rho r, f dash rho r1. F dash rho r1 is calculated from this model. See, this is f dash rho r1. See, now when you got rho r2, you're going to put it in the main model of the condition. If it is 0, this is your rho r. If it is greater than 0, then you have to look for a new rho r. Same thing, same thing. When you got the value of rho r, you will be able to use it for z and calculate z from this model. Is that clear in this case?
Yes,
And
sir.
see, guys, what is the condition? It should be close to 10 to the power minus 12. This is the condition of Fy and or F rho r. Both Fy or F rho r should be close to 10 to the power minus 12. That is almost 0. See what I'm saying? Almost 0. So if it is greater than 10 to the power minus 2, you have to look for another value of y or another value of rho r. See? So this is the analytical solution. And believe me, listen, without having the software, you will not be able to do it by hand. Because this is really very, I mean, it's not very critical condition. I mean, it's not easy to reach this one. You may need to do it many times. So the software, the codes could help you doing something like that. Now,
Sir, but I think we don't know all of the student how to use the software. Plus the coding we don't know anything about. Can we just stick with the graphical method, because this is actually hard to understand and hard to apply, especially that we don't have time to study the programming thing for now.
okay, I do agree with you part of your speech, but I do not agree with the other part. Okay, of course, I cannot say, okay, disregard the analytical solution and we are going to stick with the graphical solution. No, this is not the way. We have to know that we have two options to calculate z. One of them is the graphical solution and the other one is the analytical solution. Now, if it comes to me, I would not like to go with the graphical solution. I would like to go with the analytical solution, because right now, when you will be in your office, nobody gonna use the graphical solution. Nobody. Okay, let me look for the textbook and I'm gonna find z chart and I will let you know how much z. No, it doesn't work like this. You're gonna work on with a lot of software, so z is part of them. If you do not know how to write your code, this is your of course I'm not blaming you, but this is what you need to work on it. You have to develop your skills, how to use the software. I said nobody gonna teach you that. Believe me, nobody gonna teach that. You have to teach yourself. It's part of your responsibility, now or later. Unfortunately, listen to me. One thing I need to tell you. In my campus, in my university campus, I used to tell my students at the second year, guys, you have to develop your skills with Excel sheet, with MATLAB, with Python. I'm not responsible in the exam if I am going to ask you solving the equation using Excel sheet, or if I am going to ask you writing a code using MATLAB. No, you have to be ready for something like that starting from the second year. Now you will be graduated sooner or later. I don't know. You could graduate this year. So I don't know. I mean, it's highly recommended to know how to use this software. I don't know. I mean, it's up to you. If you need my help, I am available. Just let me know. But you need to have the software in your laptop or desktop. At least you need to have MATLAB. You need to have Python. I know that CMG you cannot get it CMG because CMG you do have to get the license for CMG. Eclipse you do have to get the license for Eclipse. Aries, IHS, pipe sim, uh, betrayal, all of them, you have to have the license. I'm not going to say, okay, go and get it. No, you cannot get it. But you can get MATLAB free of charge. You can get Python free of charge. At least you can try with them. If you do not know how to, if you do not know how to start with them, please go to the YouTube and just write Python tutorials. You will have a lot of short video tapes that could help you how to start. I'm not going to say you have to be a professional. No, MATLAB is the same. So I don't know who was talking to me. Who was talking to
It's
me?
Seja, sir.
Who?
Seja.
Ah, Saja. Yeah. So Saja, I know you may have really high course load. I know that, but this is not good reason. Believe me, this is not good reason. You will see that. Okay. Now, can I go on? I need to finish this part for Z chart. Can I go on?
Yes, sir, sure.
Okay. Okay, because what I need actually, I need to finish. I need to finish all the topics related to Z chart. Then I'm gonna go with the few examples for Z chart. So now, now let me assume that we know how to calculate Z. It doesn't matter if we are gonna go with Z chart, the graphical solution, or we're gonna go with the analytical solution. No, I'm gonna assume that we know how to calculate Z. Now, the value of Z, should be corrected. Now, two things we need to consider them when we need to correct Z. One of them, we have to correct Z for what's called non-hydrocarbon components. What are they, non-hydrocarbon components? CO2, this is non-hydrocarbon. H2S, hydrogen sulfide, this is non-hydrocarbon. Nitrogen, this is non-hydrocarbon. So if the gas stream does have something like that, non-hydrocarbon component with the hydrocarbon, of course, then the value of Z should be corrected. So this is the first thing that we need to make the correction for Z. If there is some of the non-hydrocarbon component in the gas stream. Good. What is the second? The second, we need to make the correction for Z if we have heavy hydrocarbons. Why? When we have heavy hydrocarbons, we are not going to say, okay, heavy hydrocarbons can be treated as a gas phase. No, they are not a gas phase. They should be either liquid or solid phase. Z chart or Z factor is one of the parameters for the gas phase. It's not for something else. So when we have some heavy hydrocarbons, for sure they won't be in a gas phase. So we have to find the impact of something like that on the calculated value of Z. So the first correction for non-hydrocarbon, the second correction for heavy hydrocarbons. Now, for both of them, there are a lot of methods to make the corrections. We are not going to cover all of them. You need to study that, go into the chapter 2 of Handbook of Reservoir Engineering, written by Tariq Ahmed. Okay, one of them for the correction for non-hydrocarbon is introduced by Witchart Aziz. So here is Witchart Aziz. Witchart Aziz, see? This is Witchart Aziz. Now, Witchart Aziz, this technique, Witchart Aziz said, instead of TPC, the critical, pseudo-critical temperature, we need to calculate the corrected TPC. T-BC. This is the corrected TPC. And the corrected TPC is TPC minus epsilon. TPC minus epsilon. Now, while PPC, the corrected pseudo-critical pressure, is calculated by PPC times T dash PPC, TPC, T dash TPC, TBC, B times 1 minus B times epsilon. Now, what is B? What is epsilon? Epsilon is calculated by this model. What we have here, A, B, B. What is B? B is the mole fraction of hydrogen sulfide. B is the mole fraction of hydrogen sulfide. A is the mole fraction of hydrogen sulfide and carbon dioxide. So from the chemical composition of the gas acetylene, you will know how much is the mole fraction of H2S. You will know how much is the mole fraction of CO2. So you will be able to calculate A and B. You're going to use them and you will be able to calculate epsilon. When you got epsilon, you will be able to calculate T dash BC. When you calculate T dash BC, you will be able to calculate B dash BC. See what I'm saying? Then you're going to go to the TPR, PPR and use T dash BC, B dash BC to calculate PPR, TPR. When you got TPR, PPR, then you can go to the graphical solution and get the value of Z. Is that clear? Without example, I think it will be a little bit hard to understand that. Next week, I'm going to stop at the topics of Z, and we will start solving one of the examples. Is that clear, guys? Okay.
Yes, Doctor.
Okay, Doctor.
So this is the correction method given by Richard Aziz for non-hydrocarbon. Okay, and the second correction that is more complicated, the one for heavy hydrocarbons. Let me explain it to you, and it will be very clear when we are going to solve. So this is for non-hydrocarbon. The second one is Soughton correlation. Soughton correlation. They said, okay, we need to calculate what's called hydrocarbon pseudo-critical pressure, hydrocarbon only, and hydrocarbon pseudo-critical temperature. So the hydrocarbon pseudo-critical pressure, hydrocarbon pseudo-critical temperature, PPCH, TPCH, they can be calculated using these two models. And listen, this is the specific gravity, gamma H. Gamma H. Now, what is gamma H? Gamma H can be used as specific gravity of the gas if you have a dry gas. So if you have a dry gas, gamma H, this would be gamma gas. It doesn't matter what you have in the gas. Gamma H is gamma gas. But if you have weight gas, then gamma H is the specific gravity of the weight gas minus this term for hydrocarbon sulfide, this term for carbon dioxide, this term for nitrogen, this term for water vapor. See what I'm saying? And this is mole fraction hydrogen sulfide, mole fraction carbon dioxide, mole fraction nitrogen, mole fraction of H2O or water vapor. So for Soughton correlation, you need to calculate PPCH, TPCH from these two models. And in these two models, you have gamma H. Now, what is gamma H? Gamma H is gamma gas, specific gravity of the gas itself, if the gas is dry. Good. If it is weight gas reservoir, not a dry gas reservoir, then gamma H is calculated by this model. See what I'm saying? So when you know PPCH, TPCH, then you will be able to calculate what? PPR, TPR. So, see, then this is your PPC. See, this is your PPC, and this is your TPC. And what you have here, see, PPCH, see, this is PPCH, and this is TPCH, the one calculated before. Okay, and if you look to this term is the mole fraction of hydrocarbon, because it is 1 minus the mole fraction of H2S, the mole fraction of CO2, the mole fraction of nitrogen, the mole fraction of H2O. It means that you are removing all 9 hydrocarbons from the mole fraction, And we know that the summation of the mole fraction for a gas stream, this should be 1. So this would be the mole fraction of hydrocarbon times what? The pseudo-critical pressure of hydrocarbon. And this is for non-hydrocarbon. And same thing for TPC. Now we got PPC, we got TPC. This would be very easy to calculate PPR, TPR, then go into Z chart and get the value of Z. This is the second technique, how to make the correction for non-hydrocarbon component. One thing, guys, let me, yes, okay. I need to save the, let me see, I guess, yes, here. I need to save the first section, and I will continue talking to you. So desktop, here is desktop, okay. AUK, this is one. Okay, good. Now we are good. Okay. Okay, now this is the really very complicated part. How about the correction for heavy hydrocarbons? This would be the last thing that I'm going to do with this day, and I'm going to leave. Hopefully Wednesday we will start solving at least one of the examples given to you in the textbook. This would be, all of that will be very clear to you. Now, for the heavy hydrocarbon, there is Stewart et al. Method. Stewart et al. Method for correcting Z if we have heavy hydrocarbons. When I said heavy hydrocarbons, I'm talking about C7 plus. C7 plus could be considered the heavy hydrocarbons. Now, for this case, what you need to do, you need to estimate the boiling temperature of C7 plus. The boiling temperature of C7 plus. It is not going to be given to you, but you have to calculate this one. So the boiling temperature of C7 plus is calculated by this model. So what you need the molecular weight of C7 plus. It will be given to you by BBT. The molecular weight of C7 plus. And you need to know what? You need to know the specific gravity of C7 plus. You know what I'm saying? So you need to know the molecular weight. You need to know the specific gravity of C7 plus. Then you will be able to calculate the boiling temperature of C7 plus. Now, when you know the boiling temperature of C7 plus, you're going to calculate the critical pressure of C7 plus. Critical pressure of C7 plus. Why we need to calculate the critical pressure of C7 plus? I told you that the critical pressure can be taken from the textbook, from the tables at the end of the textbook. Why we cannot find C7 plus? Why we cannot? The critical pressure, critical temperature of C7 plus. Who can tell me why? Who can tell me why we cannot find critical pressure, critical temperature of C7 plus in the textbook? Why? Because we don't know what is C7 plus.
Yeah.
We don't know what is C7 plus. Okay? So we will calculate PPC. I think we have only 1 minute and then we will be done. So for this connection, please consider that we are done. Then you are going to calculate the critical temperature of C7 plus. And then you will be calculate F sub G from this model. F sub G, see, for C7 plus. Then epsilon G, this is epsilon G. Then epsilon K, see. With the example, it will be very clear to you. Then you will be calculate J, K, and then J dash, K dash. And finally, you will be able to calculate TPC, PPC. If you got TPC, PPC, then you can go to PPR, TPR, then you can go to Z chart, and you will be able to calculate